Good evening from Wellington. Thank you for organizing this interesting webinar and inviting me with such outstanding guests. It will be interesting to hear their extensive information. By the way, Ms. Robin Galloway, co-chair of the Turkish New Zealand Business Council, sends her best regards. She wanted to join the webinar also. If she is attending already, she might like to share a few words. Otherwise, she is sending her greetings too. I'd like to congratulate you also for organizing this meeting at a time when the whole world is watching COP26. And I'm happy that Turkey participated in the conference after ratifying Paris Climate Change Agreement. Now you heard that our goal is to reach net zero emissions by 2053. The detailed strategy for this meeting, this target, will be developed early next year. Well, if we come to the subject of our webinar today, first, in a nutshell, Turkey wishes to achieve supply security in energy. Like all countries do, we therefore promote diversification of energy sources and routes. The use of renewables and alternative energy sources is an important part of this strategy. Plus, there's a need for transition. Among the OECD countries for the last 20 years, Turkey had the second highest demand for electricity and natural gas. So therefore, we are trying to increase the energy supply along with a successful transition. Second, if we go along with some statistics, we have a success story in renewables. Let's look at the numbers. For the last 5 years only, we have invested $16.5 billion in renewables. Turkey has the 5th biggest installed capacity in renewables in Europe, following Germany, Spain, France, and Italy. And we have the ranking 12th in the world. The first 11 is China, India, Japan, Russia, Canada, US, Brazil, and followed by the European countries. At the moment, 53.5% of total installed capacity is based on renewables. That's a good progress. By the end of August, probably the experts have been following, hydropower accounted for 32% of the total installed electricity capacity. Wind contributed 10%. Solar comprised 7.5%. And of course, we have geothermal and biomass, but they constituted 1.7 and 1.8 respectively. Energy and Natural Resources Ministry announced that wind power capacity exceeded the 10,000 megawatt threshold in August, when the country ranked as one of the top 10 top countries worldwide with the highest wind power and the 5th in Europe. Well, all the Wellingtonians would say that this windy valley would be the top of the top, but we who do have wind power in Turkey too. Turkey is among the top 5 countries in the world in terms of geothermal energy installed capacity. Well, here there is an interesting rank. US, Indonesia, Philippines comes first, and New Zealand is the 4th country. We are following New Zealand as the 5th in geothermal energy capacity. Being aware of the importance of hydrogen in energy, of course, in transition, we also included hydrogen in our strategy. Third, I want to say that we are open to foreign partners in energy. Turkey is famous with her vibrant entrepreneurs, They have already embraced climate smart growth. The geographic location of the country and the size of the domestic market make her an attractive investment destination. Recently, Asia Infrastructure Investment Bank, AIIB, increased its loans for renewable energy and energy efficiency facility in Turkey. They increased from $200 million to $300 million. The loans are managed with the Turkish Development and Investment Bank in Turkey. Also, European Bank for Reconstruction and Development, EBRD, is one of our biggest investors, and it pledged to fund green projects in Turkey, which will amount to almost 5 million euros. And there are Turkish firms winning tenders in Turkey with foreign joint ventures, such as solar power plant with South Korean Hanwha Q-Cells firm, or a wind power plant with Siemens. And GE started a plant producing wind turbine blades in Izmir. By the way, Izmir is a famous city on our Aegean coast, and Aegean Exporters Association informed that Turkey's first Renewable Energy Equipment and Service Exporters Association is going to be set in Izmir. They intend to coordinate and be a contact point for foreign investors as well. Turkey's renewable energy equipment exports amount to more than $5 million already. Well, when we look geographically, wind power installations are mainly located in Turkey's northwest Aegean and Mediterranean regions. Our offshore wind energy capacity is also high in Aegean and Marmara regions. In hydropower, east and southeast. In solar power, the central Anatolia, mainly Konya, are outstanding. The city is, Konya is making a great progress. These regions are standing out, and Turkey installed geothermal capacity mainly in the Aegean region again. As Metropolis Istanbul leads in biomass capacity, capital Ankara is also following Istanbul for biomass. Well, these are the regions and the names of the cities which are connected to the industrial sites also. Renewables and other types of energy developments are connected with the industrial development, you know, except residential areas. To wrap it up, I'd like to say that Turkey is a net energy importer country. To reduce the stress on the economy, Turkey promotes industrial and consumer energy efficiency, as well as climate-friendly investments. As we are witnessing the energy shortages and rising prices in Europe, Turkey is determined more than ever to progress on her energy diversification policy for energy supply security. That's all what I would like to say. I will cut it short to leave more time to our experts. Thank you for listening to me.
Okay, right now it's okay. Thank you, Ambassador Inside. I would like to ask Her Excellency Wendy Hinton to make her opening speech. Dear Ambassador, welcome again.
Thank you very much, Emin. Merhaba, good evening, good morning, friends and colleagues, and everybody who's joined this webinar from the Turkish and New Zealand business communities. I want to mention our grateful thanks, both to Emin, our moderator, and our friends from DEİK, the Turkish Foreign Economic Relations Board, with whom we've worked very closely to make this event and other events possible, and also to our expert speakers, many of whom are joining us very late in the evening from New Zealand. As we are all so well aware, there's a real sense of urgency around the need to reduce carbon emissions, including by finding renewable energy solutions and by eliminating high carbon and fossil fuels. We need to do all of this on a large scale, make it fair, safe and sustainable and affordable. New Zealand is a leading producer of renewable energy. The International Energy Agency calls New Zealand a success story for the development of renewable energy, but no one can afford to rest on these sorts of achievements. By 1995, the renewables in New Zealand's energy mix had hit 85%, and that was largely thanks to hydroelectricity generation and later to geothermal energy production and then to wind. However, green energy is not a straight line. It fluctuates as needs increase. We in New Zealand can be pleased that the renewables element of our energy supply remains at 85%, although demand has vastly increased. New Zealand is one of the few countries to have a zero emissions goal in law. We adopted the Zero Carbon Act in 2019, but its implementation remains a challenge. Being an agricultural nation like Turkey, we have a massive methane emission problem, and we have to address this. Renewable energy is one of the tools which will help us do this. Our target is to reach 100% renewable energy by 2035 and to completely stop using fossil fueled vehicles within the next decade. We have made it to the last 15%, but that is the hardest part. On the technology front, we are pushing the frontiers. We have recently started producing renewable hydrogen energy out of geothermal. We are working towards green mining and the conversion of emissions into clean fuels. We believe that with the right policies and funding support, these technologies will provide some of the answers to our energy problems. Tackling issues of scale, affordability, safety and sustainability will of course be critical. There are people working on some very big and very novel ideas, which we'll hear more of shortly from our expert speakers. Enjoy the information sharing and networking, and thank you very much for listening and for being here.
Thank you, Ambassador Hinton. After the opening remarks of our ambassadors, now I would like to give the floor to Mr. Mehmet Öğütçü, CEO of Global Resources Partnership. He is a prominent diplomat who served in the Ministry of Foreign Affairs, International Energy Agency, OECD, and many other international organizations. He is the go-to person in global energy and geopolitical issues. Recently, he also wrote a book about his days when he was a diplomat. It will be a great opportunity for all of our participants to learn about the latest issues in the geopolitical and global energy arena. Mehmet Bey, the floor is yours.
Thank you. Thank you very much. I mean, you are in Jakarta and our friends are in Wellington and Ankara. I'm in Bodrum. I just calculated from Google, I'm 18,000 kilometers away from Wellington. And it's a wonderful weather here. It's morning and Wellington is enjoying evening, as I understand. Well, New Zealand is an amazing country, which I haven't visited yet. I've been to Australia, but not yet New Zealand, in many respects. But as ambassadors already highlighted, it's a success story in many regards. In particular for our session in renewables, 84% of the energy mix now coming from renewables. I think it's due to perhaps its volcanic and tectonic features in many regards, geothermal, hydro, wind, and now I think green hydrogen is also coming to the picture. It's also a country where you have innovative high-tech for climate technologies, access to finance. So it's an amazing country in many regards to learn from and to collaborate with. So I would like to approach our subject matter from this angle. First, a few words about the world energy dynamics, which are changing day by day. I mean, a few months ago, wherever I go around the world to talk about the energy security issues, I always mention that there is an abundance of energy in oil, gas, coal, and excess capacity renewables. But right now in Europe, I don't know how it's going in New Zealand, but we are facing a very, very serious energy crisis arising from, I think, shortage of supply, imbalance between demand and supply, of course, and volatility in prices, and disruptions to many factories, transportation, what you have it. We were not expecting that. It looks that by spring, I think we are going to live with this crisis. Started in UK, but also going on almost everywhere. Turkey is also, of course, facing a similar challenge in many regards. So this is also, I think, a reflection of the painful transition we are going from fossil fuels, represented by oil, gas, and coal, to renewables, the wind, photovoltaic, solar, geothermal, hydrogen, and all other areas of renewables. And also, this is going to be very painful because we still depend on fossil fuels for the foreseeable future. It's not going to go away. We're not going to have 84% as in New Zealand renewables. In many other countries, think of China, 80% of electricity generation coming from coal, and Poland and other countries, or France, 75% from nuclear. And technological breakthroughs, we cannot catch up with technology. It's changing so fast. I mean, green hydrogen now, also in solar and wind. If you go to China, you see the combined facilities bringing together hydro, solar, and wind. It's amazing. They are spending as much as US and European Union combined, renewables, innovation, and technology. Then digitalization is a huge blessing for us, but it's also a huge risk because of the cyber attacks and many other disruptions. And so technology is a blessing, but also a disruptive force that we have to bear in mind. Then decarbonization. So as you said in the beginning, so now we are still about to conclude the Glasgow summit. I don't expect much to emerge from this summit, but it's a building block, you know, Kyoto, Marrakesh, Copenhagen, Paris, and now Glasgow. I think we are moving in the right direction, but it's going to be very difficult to achieve global consensus, even about 2050 decarbonization goals, which I believe New Zealand will reach this much before it happens. I remember listening to Helen Clark decades ago. Her speech was almost 70% about climate change when nobody was talking about it. So now, by 2035, as Ambassador said, New Zealand will be reaching 100% renewables. This is a huge achievement. Yes, I agree with you that this is a success story in many regards. I don't think any country were able to replicate what New Zealand has done in this regard. So there's so much to learn from that. And also, as Emin mentioned, we are not short of geopolitical tensions, but these tensions will change a bit because we have a new geopolitics of energy. In the past, it was more on fossil fuels, oil and gas, access to these scarce resources, then also the shipping lanes carrying this oil and gas through pipelines or LNG or crude tankers, then choke points like Malacca, Hormuz, Gibraltar, Suez, Turkish Straits, and Panama. But now we are talking about access to lithium, cobalt, and nickel, which will be oil and gas and coal of the future. These are needed for renewable batteries and all other new sources of energy. And therefore, geopolitics will be changing somehow. It will probably be less tension because there will not be pipelines crisscrossing the country's transit arrangements. However, as I said, there will be different sources of tension. Geopolitics will never leave the scene, and energy and geopolitics will not be divorced. We cannot treat them in isolation as today. Financing is, I think, is a key issue. I always say, follow the money. Although I'm a former diplomat, I focus so much on geopolitics, tensions, security issues. But I think what matters, I learned in IEA, OECD, and now in the private sector, where I run the energy business, and the money is the key. And what I witnessed, I'm the chairman of London Energy Club as well. We had a meeting 2 months ago. I brought together all the financiers of the world in energy. And the key message was, we will not finance fossil fuels. But that's a political preference, actually. And then this sends a message, signal to all the investors as well. As a result, we see that everybody is now busy with greening their technologies, energy, environment, trade, investment. One example, of course, the Green Deal, which we call Yeşil Mutabakat in Turkey, is going to transform our lives. And Turkey is one of the most advanced countries, even more advanced than some of the EU countries in adopting Green Deal principles and criteria, working very hard on that. So I think Ambassador Ünsay gave an excellent picture of Turkish energy outlook in terms of where we stand and where we are leading towards. And for Turkey, this is the 16th largest economy if you calculate on the basis of purchasing power parity, and 6th largest in Europe. And energy is a critical element in our development strategy. It's not a matter of just, demand and supply situation. It's the energy security and national security matter, because we depend 75% overall on imported energy, 98% in natural gas, and 93% in oil. It's a huge vulnerability, although it creates also some sort of interdependence, like with Russia, because we are the 2nd largest client of Gazprom in the world after Germany. And Turkey imports around normally 50 BCM of gas, but this year is going to be a record year, 60 BCM. And we are going to be in short of supply. And this is one of the reasons why we have price increases and some sort of tension on how to do this through perhaps LNG more flexibly. And I think on renewables, Turkey depends, again, heavily on technologies imported from abroad. Denmark, Germany in renewables, perhaps China, I think, more and more on photovoltaic power. And geothermal, I think we work with Iceland. I don't know to what extent Turkey is working with New Zealand, because there's a huge potential, as I understand, given that geothermal is the main component of New Zealand's energy mix. And so I just learned today from Ambassador Ünsay that Turkey ranks 5th and New Zealand ranks 4th in the world in terms of geothermal. So as Emin said, there's a huge potential for Turkey's growth in renewables to catch up its 2053 decarbonization goal, because also we signed the Paris Agreement on climate change back in 2015. However, we have not ratified for long. We drag our feet, but President Erdogan announced during the United Nations General Assembly that Turkey will be ratifying, and he followed his promise. In October, Turkey ratified it. Now there's a big challenge of to comply with the requirements of the climate change, like in other countries as well. I don't think any country except Bhutan will be respecting its compliance and commitments under the Paris Agreement. But we learned that this is not something that you take or leave it, and there are very serious sanctions, commitments that will be monitored. Hence, I want to highlight once again that New Zealand is a success story. Turkey is an emerging success story in renewables and green technologies. Although the distance is too big, 18,000 kilometers, but I'm sure in today's age, distance doesn't matter much. So we have to find areas where there is win-win benefit for both sides. And so like DEİK ambassadors and also entrepreneurs, financiers, we can make it happen. There are so many opportunities to explore multilateral framework, bilateral, regional. And I think rather than governments, which should provide the strategic framework, I think the real burden is with entrepreneurs like Emin Hütay and others going around the world, bringing key stakeholders together, putting the finance behind it. And this is how the cooperation turns into real business. Therefore, I'm happy to be on this screen together with you. I hope one day whining and dining will be better to engage in such a dialogue rather than Zoom. I'm sure this day will come. Thank you for the opportunity given to me to talk about this matter.
Thank you, Mehmet Bey, for your insightful speech. Now, I would like to introduce Mr. Mike Allen, New Zealand Special Envoy for Renewable Energy and Executive Director. Even though New Zealand is blessed with natural resources and has relatively small population, the country is still focused on decreasing its need for hydrocarbons. It's a true example to the world. As you are the executive director, we would like to hear New Zealand's success story on renewable energy development. I'm also personally curious about how geothermal plays a role in the country, as I'm interested in that subject.
Thank you very much. And thank you, Mehmet, for your very useful introduction and explaining more about the geopolitics. We have had a long association with Turkey, not so recently in the geothermal business, but some of my early colleagues in the 1960s were working in Kızılderili and other places under United Nations programs in very early days. So we do have a connection with Turkey. And I know there are a number of groups from New Zealand who are involved in some of the ongoing geothermal work. I make no apology, my background's in geothermal, so my presentation is going to sit on that a little bit heavily, but I want to try and see if I can share the screen, please, and present a PowerPoint to you and run through a variety of issues quickly, because there are other people who are going to follow me. Seem to have lost that. One moment. Can you see the screen? Can you see the PowerPoint okay?
Yes, we can see.
Okay, thank you. So what I want to do is talk a little bit about balancing our energy needs and decarbonisation in New Zealand. And as I say, I make no excuse that it is quite heavily focused around some of the geothermal issues. But despite the comments that we've had in the last few minutes about New Zealand, this is a live screenshot of our generation in New Zealand at 11 o'clock this morning. I'm very proud to show you that at 11 o'clock this morning, 91% of our electricity generation in the country was from renewable resources. And you can see on the right-hand side here, the contribution particularly from hydro and wind, hydro and geothermal, a little bit of gas. And there are two sections here because we have two areas of generation, one in the South Island where there's predominance of hydroelectricity, and in the north where again there's a lot of hydro but also geothermal. So the renewable renewable electricity contribution is well established. As has been mentioned, it typically sits at about 84 or 85%. And so this varies during the day depending on where the source is coming from. Sorry.
So sorry to interrupt. We cannot see your PowerPoint screen at the moment. Really sorry to interrupt you.
Let me try again.
Yes, we can see it right now. Yeah.
Can you see that now?
Yes. Right now is okay. Okay.
Can you see that okay?
Perfect. Yes. Thank you.
So you can see the renewable electricity contribution one.
Yes.
That one? Okay.
I can see the, yeah.
Okay, so from an electricity contribution, you know, we've made good progress, and some of the others will talk about some of the things we're doing here in New Zealand. So the target of 90% by 2025 is easily achievable, I think. 100% renewables is a challenge for any country. New Zealand will push on towards that. But in the electricity side, we're catered for. Where our real challenge lies is outside the electricity sector. And Hinton has commented on this, that, you know, we have about 30% of our total energy demand is covered from renewables, including the electricity. And so our focus in trying to decarbonize is going to be around what we can do with the industrial electrification. We do sadly still use some coal, particularly in some of the agricultural processing industries. We're looking very focused on what we can do with electric vehicles, and obviously with the renewable energy, that's a good situation to have. And Greg will talk a little bit later about the green hydrogen production and what we're doing domestically. And this is a relatively new effort by New Zealand, but particularly around long distance haulage. So the challenge for us is to find something that can substitute for the fossil fuels that we use for transportation. The Ambassador has also mentioned about our Zero Carbon Act, which was enacted in 2019. The goals have also been mentioned, and the challenge that we share with Turkey around our agricultural environment, and that we have a very high biogenic methane emission, which we have to compensate for. A lot of work is being done to try, obviously, to reduce the production of methane, but that is challenging, seeing that we're based very heavily in agriculture in terms of our economy. So the government has established a climate change commission, and this commission is providing guidance to the government. It's a bipartisan arrangement, so this won't be changed if government change is undertaking to maintain this and drive this forward. But as the ambassador has mentioned, it is still quite a challenge. To talk a little bit about some of the geothermal work that's been going on in New Zealand, because it is an important part of our generation. As has been noted, we have predominantly hydroelectricity. At the moment, we have about 85%, as we've said, of New Zealand's electricity coming from renewable resources. And geothermal contributes somewhere between 17 and 20% of that. And there's still a significant amount of geothermal that can be added into the system. As in many countries, hydroelectricity is a difficult thing for us to expand. The environmental concerns around hydroelectricity are challenging in most countries. And so I don't think that we will see significant new hydroelectricity. So we are developing our wind resources, which currently provide about 6 to 7% of the generation. And we've got a very new and nascent market in photovoltaics. PV has not been a focus for the country in the past, and this is now being driven forward by private sector groups. And one of the things that I think you need to understand, which differs between Turkey and New Zealand, is that in the development of energy in New Zealand, it's completely driven by the market, by a combination of state-owned enterprises and private sector players, and there is no financial subsidy, there are no feed-in tariffs for preferential renewables, and so everything has to be something that will sit commercially and viably in the market, which I think is a very important driver. And it has been mentioned, financing is critical and the returns from energy are modest, so we need to choose things that are viable and can be driven forward. So our geothermal sits in the northeastern part of the North Island. This is the predominant area where we have geothermal. We have a large number of geothermal resources and fields. We have a system which has already categorized these into fields which we're allowed to develop and others which are really only there for cultural purposes and will never be developed for power. But we have a number of 15 or so fields which are high temperature resources and which are available for geothermal power production. The regulatory setting in New Zealand, which controls the development of geothermal resources and a lot of other natural resources, is known as the Resource Management Act. For geothermal, this has been quite beneficial, and that it's a one-stop shop in terms of getting permitting to be allowed to do development. New Zealand is a little bit unique in that the geothermal resources are controlled by the landowners, and I'll talk about that in a moment. And direction is largely given from central government, but is controlled by national policy statements overseen by regional entities. And as I've said a moment ago, it's very important. The market here is completely deregulated and there are no subsidies, so each of the things has to stand on its own. And with all natural resources in New Zealand, whether it's water or geothermal, the Maori, the indigenous Maori, have a leading role to play in development. They have a strong ownership role in terms of the geothermal markets. And so the Maori undertakings in terms of looking forward about how we develop resources, not only from an energy security point of view, but from an economic and cultural point of view, are critical to us. And so many of the new geothermal fields that are being developed have a Maori-owned involvement. And sometimes that is as high as 30–40% of the equity is owned by the indigenous landowners. And this is a very important part of driving development forward. And the Maori themselves are leading a lot of innovation, which is going to see, I think, better use of geothermal in the future. As in many countries, we have a large scope for geothermal. We sit in sort of the moderate temperature areas, and here where we've been doing power development, in the lower temperature areas because we don't need so much heating. We haven't really developed that, but we have for many, many years had quite a heavy commitment in the industrial sector, particularly pulp and paper, where geothermal was used in the process, and it's been doing that for almost 60 years. And we're now starting programs to look deeper into the resources to see where we can get even higher temperature geothermal resources. But there are many opportunities to support decarbonisation right across the spectrum, and geothermal is quite a critical one for that. We have some new plants that are going in. There's a new plant which has just started construction in the centre of the North Island. He's the Prime Minister at the spudding-in ceremony. So this is a 152 megawatt plant owned by one of the major utilities in New Zealand, and will be online in the next couple of years. One of the things about the decarbonisation clearly is that whatever technologies we use, we have to be conscious of emissions. And geothermal has been challenged in that all geothermal plants do produce carbon dioxide in small quantities. And here you can see a comparison between wind, hydro, the solar and geothermal in terms of renewables, and obviously coal and gas at much higher in emissions. And the geothermal industry in New Zealand is very focused at the moment on the opportunities to get rid of the CO2, and there are major programs going on with the major utilities for actual re-injection of non-condensable gases, and this is very important for us. And I understand that in Turkey in particular, CO2 has been a big challenge around the geothermal markets in terms of the emissions. So these are areas that we could talk about. The re-injection process is really very new. It's just being trialled by Mercury, but we'll have a lot of information on that shortly. And geothermal has been quite a contributor over the last 15 years or so. As you can see, the geothermal on the bottom here has been increasing. It's been pulling down the actual total emissions, and also the emissions intensity have been falling because geothermal has a much better ratio of CO2 to power production than other technologies that we've been displacing in terms of gas and coal. We are also doing quite a lot of work around geothermal, which is related to the broader opportunities. There's a commercial plant now for the extraction of silica, which has a commercial value, but it also allows us to improve the efficiency of the geothermal plants. And very excitingly, we are now starting a plant which will start to produce lithium. And obviously, as has been mentioned, lithium is very important for battery production and for the wider use within renewables. So we're starting to look at other sides of the market. We're doing quite a lot of work around artificial intelligence and machine learning approaches to optimizing the use of geothermal to get the best value from it. And there are a number of companies you're already familiar with, those of you in the geothermal industry, Sequent, who are world leaders in modeling software that are out in the market. So that's where I'd like to wrap it up and come back to the discussion that we had a little bit earlier, which is around the opportunity to share information. We have a lot of New Zealand companies who have been very heavily involved in the domestic market here, but we have a history, and I've been personally involved over the last 40 or 45 years working internationally, and we've learned a great deal from those international collaborations and would be very keen to build the relationships with Turkey in whatever ways we can in the Turkish market or in third markets. As Iman has indicated, he's in Jakarta, and I had the privilege of building the first geothermal plant in Indonesia. So we have opportunities to collaborate and would look forward to that. And I look forward to hearing the rest of the discussion from you all. Thank you very much for the opportunity to talk tonight.
Thank you, Mr. Allen. I would like to turn to Mr. Greg Thompson, CEO of MB Century, for his speech. As stated in its website, MB Century is an energy sector service provider company that delivers a reliable and sustainable future. It serves geothermal and hydro industries. The company operates New Zealand's largest geothermal drilling rig for exploration, production, and re-injection wells. Mr. Thompson, the floor is yours.
Thank you, Man, and welcome to everybody on the call. It's fantastic to participate in this event. It's great that to see everybody sharing the knowledge, and hopefully, as Iman mentioned, I'll share our story, how we enable the energy sector to deliver a reliable and sustainable future. It's also interesting to hear the Turkey battling with the energy trilemma, this being energy security, sustainability, and equality. These three pillars, finding that right balance is really important as you move through the decarbonisation of your country's energy use. I'd just like to share our presentation quickly, if I can. All right. Can I just check that you are seeing our presentation?
Yes, we can see.
All right, excellent. So just a quick overview of who Nbc is. We're a 100% owned New Zealand company, and more importantly, we're also a Maori-owned company. This being Tuara Paki Trust, who owns us 100%. They've been around for since 1952, and they've actually developed their own geothermal power station. So they own the power station and the resource above it. Mercury, one of the energy companies, has an equity share of about 25% of it, and they also do the operations of the facility. Over the years, we've specialized into geothermal and hydro engineering. This has been great as we've diversified and got into new areas, but also really focus in the renewable energy side. We've worked in New Zealand and internationally, and we've come out of the Ministry of Works days, who set up the facility, but also through that, we've built up 70 years of experience. Just a quick overview map of where we've worked internationally. So right across the globe, wherever there's a geothermal resource, we've participated in that, but also operating in many countries in terms of the hydro energy sector. What do we do? Key things for us is the geothermal development. So we're into the consultancy side, so helping facilitate that. We're into well design, but we also do the geothermal drilling. A couple of other things to mention is that we've been in the construction of geothermal steam fields, but also the geothermal construction of the power plants as well. Through the years, we've built up a great facility where we do some heavy manufacturing of pipework, precision engineering, and also some industrial coatings. So we operate and own New Zealand's only geothermal drilling rig, dedicated drilling rig, which is Rig 32. It's currently on the Tauhara field, which is the contact energy development of a 152 megawatt power plant. We're looking to drill about 12 to 16 wells for them, and each well takes us roughly about 8 weeks to complete. And this can range anything from 1,500 to 3,000 meters in depth. The key thing for Nbc as well, we haven't aligned ourselves with any original equipment manufacturer. So we work alongside many of the major OEMs in the world. So this being Fuji Electric, Ormac, Toshiba. We partner with them. This enables us to understand their technology and ensure that the facilities and the designs integrate really well. As mentioned by Mr. Mike Allen earlier, we've also diversified into the hydrogen. We've actually been responsible for building New Zealand's first green hydrogen facility. This is connected to the Mokai power plant, where we're actually drawing about 1.5 megawatts of energy from the power plant, and we're manufacturing green hydrogen. It is a pilot plant, so we're working through the economics, but also the operations of that. And we see that really as a key vehicle of decarbonising New Zealand, especially on the heavy vehicle movement of our transport side of things. I don't think that electric vehicles is the only solution, there will be a multiple solutions. And I think hydrogen plays a key part in delivering that. A quick overview of New Zealand's key geothermal power plants and where NbC has played a major part in the development of these, but also the ongoing maintenance of these. So the likes of Ngāwha, Ngāpurua, Mokai, Te Mihi, Ngātamariki and Kawerau. It's part of the development of them, but also the ongoing servicing of these power plants. Rig 32. So we procured Rig 32 from Drillmec, which is an Italian company in Europe, but it also allows us to drill significantly big holes. So they're about 30 inches in diameter, and our deepest well that we've drilled to date is 3,650 meters. So very capable drilling rig. We've modified it so it can drill into high temperatures. So we're reaching over 300 degrees C in the areas where we're drilling. Our reservoir logging. This has really been an area of innovation for us. So we've built a number of our own tools, and this is really looking after the geothermal well. So in Maori philosophy, they believe that if you look after the land will look after you. So the key thing for them is actually looking after their resources. And through the ownership of a Tuarapaki Trust, they've really driven the innovation of the company. And we've actually developed what we call a multi-finger tool, which is shown in the bottom of the slide. And this tool is quite unique in terms that it's able to explore and evaluate internal and external corrosion of casings, but also through their multi-fingers, it's able to give you live feedback if there's any corrosion and do the data logs of these wells. We've recently just won a New Zealand Innovation Award for this tool, and we're over in Mexico currently on the Guatemala geothermal field. We're doing a number of 4 geothermal wells and logging the corrosion and the condition of these wells to see how we can improve their production facilities. Our engineering team, across the business, we employ about 145 people. Part of our engineering drilling team, our engineering team and design, they're actually doing quite a lot of the designs, especially pipelines and all of that. They also look at the 2-phase impact of bringing geothermal up into the geothermal facility, as this can be quite turbulent flow and there is potential for water hammer. So we do all the process analysis within our company, but we also help clients develop plant specifications and contract employer requirements, as well as construction support and advice as they get through development of power plants. As mentioned earlier by Mike, Mercury are busy with the CO2 injection, and NbC have been partnering with Mercury on this, and how they actually and have been heavily involved in the design of this. So looking forward to the success of how do we actually reduce the carbon on geothermal plants and make them more efficient. Just to wrap it up, some of our facilities, we do have fabrication, machine shop and industrial coatings. However, on our mechanical services side, we've really driven into the geothermal side of things and around the turbines and critical equipment, as well as deploying some critical maintenance applications like laser alignment, balancing, photogrammetry, but also we've developed some key expertise in-house who actually help clients through some of the difficulties of selecting key plants as they look to build their facilities. Iman, I'd just like to end it off there and leave any questions or that to the end of the session.
Thank you, Mr. Thompson. We can get questions at the end of the session, I think. It's better.
Okay. Cool.
Turkey and New Zealand can get together for geothermal capabilities as they are the world's fourth and the fifth largest players. Last but not the least, we have an interesting company that combines biology and energy. Mrs. Babette Peterson, how can I call you? Babette?
Babette is excellent. Thank you very much.
Babette, okay. Ms. Babette Peterson, Vice President, Europe of LanzaTech, will be providing us how the company's carbon recycling technology prepares a better and greener world for us. It is very innovative that pollution is converted by bacteria to fuels and chemicals. Ms. Patterson, the floor is yours.
Thank you very much. I'm going to try and share a screen with you. So if you can let me know if you're seeing that screen. Can you see the screen?
Yeah, it's very clear.
Okay, perfect. Yeah. Thank you so much. And good morning, Turkey. Good evening, New Zealand. It's really a pleasure to be here, especially as some of you may well know that the LanzaTech story actually started in New Zealand. So I'm going to share with you a little bit about that background, but more importantly, how the company has grown from the New Zealand base out into the world. And it's less about renewable energy and more about something that is now being called renewable carbon. So in brief, what does LanzaTech do? Two things mainly. One, we capture carbon from different sources, from waste sources, mainly industrial carbon emissions. So it addresses the question that came up just earlier about how do we do that, particularly if it's a gaseous source. And LanzaTech's invention was around gas fermentation. We transform those carbon-rich gases into sustainable chemicals and fuels using a biological process called fermentation. So as it's quite a complex process, I thought I'll just start out by giving you a little bit of an overview at the highest level of what that actually means. LanzaTech has over 1,000 patents, and actually most of those are around what you see in the middle of the slide, which is effectively the fermentation process by which a gas is captured, cleaned, compressed, and we have a naturally occurring bacteria, which we call a biocatalyst, which actually ferments that carbon and produces products. The first product we've produced is ethanol. That's commercial today. And we've been able to convert that into a very broad and somewhat surprising range of end uses. The more familiar ones are things like transport fuels, both sustainable aviation fuels and road transport fuels. But some of the more novel ones that you see on the bottom right-hand side there are effectively unexpected in the sense of ranging from fine fragrances, luxury perfumes, all the way through to dishwashing detergents. And I'll talk a little bit about those later on. But the key thing on the left-hand side is, what is the source of carbon for this process? It's effectively waste industrial emissions. And as was mentioned earlier, that is an issue in Europe. It's an issue globally. In Europe, we don't have the Zero Carbon Act as you do in New Zealand. We actually have the Green Deal, which, as was said earlier, is driving a lot of what we do in providing the framework for the targets and also the climate action plan. So energy intensive industries are critically trying to reduce emissions. And what we do is to valorize those through products that you see on the right-hand side. We started with steel because the steel gas composition contains a mixture of carbon monoxide, carbon dioxide, and hydrogen in the gas. So we don't need to bring in any external energy sources like hydrogen. And of course, we've also developed the use of solid waste. So we can actually take municipal solid waste, agricultural waste, even wood waste and plastics waste. Now there's an extra step there because that has to be gasified to produce the syngas that is then taken through exactly the same process as the industrial off gases. And in cases where the ethanol is developed downstream into polymers like polyethylene and polypropylene, those plastics at the end of their life can be used to feed the process to give circularity to what we do. The process that's least developed, but we're working hard on it right now, is the one that actually captures CO2 either directly from air or from industrial processes. And as that process requires both electrolysis and green hydrogen, it's one of the reasons why it's the least developed. Technically, it's possible, but as we all know, the availability and the economics of green hydrogen electrolysis are not exactly where they need to be today for economic processes, but we are developing that actively. On the right-hand side, I'm going to go for a few moments to sustainable aviation, where we are working in New Zealand. We do reduce the emissions in aviation by over 70%, as well as reducing the contrails, which are the SOx and NOx impurities that are released into the air in aviation. But working now with direct air capture firms, and we have a project in the UK to take that carbon dioxide from the air and also feed it into this same process. On the right here, you see the one bioproduct that we have is actually a high protein that we use for animal feed in China today in our plant. That is actually the spent biomass from the bioreactor in the middle of this process. And on the bottom right, as I said, we've developed consumer products ranging from detergents to fine fragrances, and I'll tell you a little bit more about those in a moment. The 2.0 up there, the purple box, just means that LanzaTech has developed not just one biocatalyst to make ethanol, but we actually have a whole family of biocatalysts to make chemicals other than ethanol directly. So today we use ethanol as a building block. Tomorrow we'll be making the chemicals directly using the gas fermentation process. So as I said, it all started in New Zealand. That was certainly well before my time. There was a first pilot plant in Glenbrook, working with BlueScope. So as I said, the origins in New Zealand, and based on that work, we were able to actually take that, as I'll show you in a moment, out to the rest of the world. And what do we have in New Zealand today? The focus has shifted to highly skilled work, mainly PhDs. Our metabolic modeling group is in New Zealand, artificial intelligence work that we're doing. We cover global fermentation activity. And of course, our early investors were in New Zealand. And today we're part of a new consortium on sustainable aviation fuels, part of the governing body. So we remain active in that market. But what's happened in the rest of the world, many companies like LanzaTech have a really hard time going through what we call the valley of death. In other words, coming back to Mehmet's point, it's all about the money. You've got to be able to finance moving to commercial scale. And LanzaTech did this in 2018. This plant on the top left-hand side that you see there is Shaogang Steel in China, which is a joint venture with LanzaTech and has been operating since 2018. So rather than just a conceptual diagram that we showed you before, this is actually working operationally, is commercial, and this facility has produced over 100,000 tons of ethanol to date and avoided over 150,000 tons of CO2. So we believe the technology is entirely de-risked, and that's enabled us to put together a project portfolio across the globe using different carbon emitters as feedstocks. And on the top right-hand side is one of the reasons why I joined about 2 years ago. The first European plant is being built in Ghent in Belgium by ArcelorMittal, the global steel company. And that plant will have a capacity of 60,000 tons and will be operational at the end of next year. This plant, we continue to innovate wherever we can. And this plant is innovating in the sense that the coal that they use to feed the blast furnace is being replaced by biocoal. That's effectively torrefied wood, so that the ethanol produced by this steel plant will actually be certified bioethanol, and therefore will be qualified for sustainable aviation fuels, as well as biogenic carbon sourced for consumer products. In the bottom here, you can see the projects that we can announce. We're obviously working on many more than these, but as you can see from this, we will have about 3 plants in China by the end of this year, not just steel plants, but also ferroalloy plants. We have a plant being built in Japan based on municipal solid waste, 2 plants in India with refineries. We're working with plastics waste in Europe, and we have projects going on in the US as I speak. I always like to show this slide, although it's not necessary, but what's incredible, if you look at that left-hand picture, is how you can take unsorted municipal solid waste, which looks exactly like that, and transform it using LanzaTech's gas fermentation process into ethanol, which is actually a clear liquid, looks like water. And in this particular case, we've worked with Sekisui since 2014, many years, lots of data. And they finally decided this year to go up to commercial scale. They're building about a 20,000 ton plant in Tokyo and have made a partnership with Sumitomo Chemical, who will transform that ethanol to manufacture polyolefins, which we call carbon smart, based on recycled carbon. So we started out using ethanol as a building block for fuels and chemicals. On the left-hand side, you see the aviation work. That's our CEO, Jennifer Holmgren, and the chairman of Virgin Atlantic. We actually flew a Virgin Atlantic flight from Orlando to London using a blend of LanzaTech's jet fuel. I also wanted to show this because, of course, we've not done this alone. As you can see on the bottom there, lots of different partners we've worked with to get to this point. But what you may not know is that the LanzaTech aviation fuel process is a separate patented step beyond the gas fermentation to ethanol. And on the right-hand side, you see some of the consumer goods that I'll talk to you about in a moment that have been developed, surprisingly, from the carbon captured from these emissions. So this is just two words, since we're working in New Zealand on sustainable aviation. This is the process that we've developed and patented to take ethanol, either our ethanol from carbon emissions or any source of sustainable ethanol, to jet and diesel fuel. And we were very fortunate in 2020, last year, in the middle of the pandemic, we spun out a company called LanzaJet with funding from the people that you see in the middle here to build 7 commercial plants to produce commercial quantities of sustainable aviation fuel. I'm sure in New Zealand, just as everywhere else in the world, there are some very ambitious mandates for sustainable aviation fuel blending. As you can see there, we'll be producing 150 million gallons in the 2022-2027 timeframe. That's a drop in the ocean of what's needed, but still we feel a contribution to the targets. So as I said, in the aviation fuel, it's a 2-step process. First of all, the gas fermentation to ethanol, and then the ethanol is converted to jet and diesel fuel. In exactly the same way we've worked in the consumer goods industry, and this was one of the first projects announced with L'Oréal, the consumer goods company, where we partnered with Total Energy, who take our ethanol, convert it to ethylene, and then polymerize it to polyethylene in their existing facilities. And that is used to produce this lovely packaging that you see from L'Oréal that they will be launching to meet their sustainability targets in 2025. And we've been delighted that Unilever has taken up this technology and is using our carbon smart ethanol to produce surfactants that they formulate in detergents. The first launch was an Omo detergent in China. And 2 weeks ago, they launched a hand dishwashing liquid in South Africa. We're also working in the textile space. You can take our ethanol, it gets converted by downstream partners like India Glycols to monoethylene glycol, and that is used to spin polyester fibers by Far Eastern New Century in Taiwan. And actually this week or next, there'll be an announcement by a major fashion retailer globally about the use of this fiber in apparel, fashion apparel. And we had a launch from Lululemon, which is an athletic apparel brand a few months ago, using this same technology. We can also use these polyester resins for packaging applications. So to earlier points about what you do with these carbon emissions, well, number one, we capture them, but number two, we create value by converting them to the types of products that you see here. And as I said, we had initially sustainable aviation fuel as a target, but have been very positively surprised by the take-up in the market and by the global brands of the technology in these different consumer applications. And the first one, I mean, the ethanol can actually be used as is, as you can see on the left-hand side here. This is a big Swiss retailer called Migros, and they converted the ethanol that they use in their household cleaning and detergent products into our ethanol. As you can see on the bottom left there, these are labeled as based on CO2 from emissions. And interestingly, the consumers are reacting very positively to this, and they moved on the right-hand side to actually use the carbon smart polyester for their packaging as well. So they have carbon smart inside and outside. And this is the Coty announcement. Coty have about 8 luxury perfume brands. Some of you may be familiar, Calvin Klein, Hugo Boss, Bottega Veneta, and they are going to convert all their bioethanol to our carbon smart ethanol in that fragrance range. And we always used to say, for those of you who've heard our CEO, Jennifer Holmgren, speak, our dream was that consumers would be able to choose their products, their consumer products, on the basis of where the carbon in those products came from. And this year, Unilever made our dream come true, certainly in terms of launching this thing called the Carbon Rainbow. If you look it up on YouTube, it's kind of cool. And they actually are now characterizing the carbon in their products based on where they're sourced. And as you can see here, obviously there are many sources. Lanztech is just one solution contributing to decarbonization, but we're very proud of being the purple part of Unilever's rainbow, which is effectively the carbon cut that comes from recycled emissions. So what we're actually doing is redefining supply chains for fuels and chemicals from waste feedstocks, waste emissions, solid wastes, and contributing to decarbonizing the economy in that way. Thank you very much for your attention.
Thank you, Ms. Patterson. Hopefully the whole world will be carbon smart one day.
Thank you. We hope so too.
We also have Robin Galloway with us. She is the co-chair of New Zealand Turkey Business Council. I also would like to give the floor to her for her valued contribution. Robin? Robin,
hello and welcome everybody. I wasn't actually preparing to speak tonight, but I've been very inspired by the presentations. And I think the thing is that even though we are 18,000 kilometres apart, as was mentioned, that really technology has already shown us that that is such a small challenge. And the bigger challenges that we face in the world together. And it's exciting to see, well, we've always been keen on geothermal, but I was very inspired by the last presentation, and I'm buying some of the, it's great to know that when I'm buying some of those products, I'm actually helping the world. But thank you very much for the opportunity and for the inspiration that's been shared tonight. And we look forward to a much more sustainable and green future.
Thank you. Thank you, Robin. As I said in the beginning of my speech, I would like to give the floor to our additional participants who will be joining after our panelists. Now I would like to begin with Mr. Diego Miller of Hamilton Jet. Mr. Diego Miller.
Hello, everyone. Thank you very much for the opportunity to speak here. I too am very impressed with the level and the quality of the presentation so far. So I hope I can stand for the same level with the brief presentation that I prepared. Let me share my screen and show you some slides of what we've been doing at Hamilton Jet in terms of green energy. To begin, I'm just going to show you very quickly what is our product. You know, we produce water jets, and water jets are a means of maritime propulsion. It's equivalent to a propeller in a propeller boat, but without the appendages below the hull. It's a very simple system. It sucks water from below the hull and throws at the back, causing a change in momentum in water and making the boat move forward. Here's an example of that kind of application. You can see the 4 water jets at the back of the boat. People tend to think that we produce engines, but we don't. We just manufacture the water jets. And the controls for those water jets, the levers, the throttle levers, the helm, and all the electronics and intelligence that are behind that system of propulsion. For many years, our products haven't changed very much, especially the water jet. It's been seen very small and gradual improvements for around 60 years. And over that time, virtually 100% of the vessels that use our water jets were powered by some sort of internal combustion engine burning fossil fuels. But over the past 5 years or so, there's been a rapid change in many areas in the maritime industry. And we recognized 3 main ones: autonomy, digitization, and electrification. At Hamilton Jet, we are doing work in all those 3 areas. Quite aggressively, we want to be part of these technologies revolutions that are taking place. But I'm going to focus on the electrification and hybridization for today's presentation, which is the most relevant topic. To cater for that market and to help with that revolution, electric revolution that we are seeing in all industries, particularly in the land transport, but also starting to see in the marine industry, we launched a project called EHX, where we incorporate electric equipment into the propulsion lines. That can be in the form of a pure electric system, which is very simple, or as a hybrid system, like you can see on the screen. The problem with the marine industry is that in order to move a boat along the water at high speeds, it requires a lot of energy. It is a very energy hungry type of transport. And by the way, the maritime transport around the world is responsible for around 2% of the carbon emissions. So the problem we have today with converting all boats to electric propulsion is the low energy density of batteries and the weight of batteries. So in order to go long distances at high speeds, which is normally what our customers do, that's why they choose water jets, they need vast amounts of energy on board. So that is one of the barriers that we see at the moment. So what we did is we created a product that incorporates some elements of electricity into the drivetrain. So that helps reducing emissions, not eliminating them completely. But we are also working on full electric systems. They are normally for short journeys, not for deep sea going vessels. Normally used for commuter ferries around cities, so very short distances traveled in between charging. And what we are expecting from the technologies that are being developed right now is increased energy densities. And I think one of the most promising technologies for us is hydrogen fuel cells. In that regard, there are two difficulties. One is the access to hydrogen for the marine industry, and the other one is the cost and the maturity of the technology. It is well developed for the marine industry, sorry, for the automotive industry, but not so much for marine. So that is where we see the technology going, and we at Hamilton Jet are willing to support that as much as we can and offer products that can help with that transition into greener technologies. Another thing that we realized that is important for our customers, and they find it difficult to solve, is the knowledge that not very many people are familiar with these new technologies with electric drives in marine industry. So they look for expertise in in their partners, and we've been trying to do exactly that, to offer advice and technologies to our customers. So yeah, that's what I had to present. We've got a picture here of our latest test boat we acquired recently to design and develop these technologies and to do demonstrations as well, so we can show to our customers and have them experience the technology for themselves. So that's all I had time to say. I thank you very much again for your kind offer to for us to present here, and I will say goodbye here. Thank you very much.
Thank you, Mr. Miller. Now I would like to turn to Mr. Chris Mann of MTL.
Thank you, Omar. I will share my screen if I can make this work. Can you see my screen?
Not yet.
Not yet. We see only you.
Can you see it now?
Again, you. The presentation is you, as far as I understand.
Maybe that way.
It's okay. It's okay.
Now I'm going to find my way back around. Sorry. Okay, is that all right? So thank you for the invitation to speak this morning in Turkey. I've really enjoyed the presentations that I've listened to. Some of the technology is quite extraordinary. Some of the LanzaTech stuff that is presented, and the Hamilton stuff. I find that stuff quite extraordinary, the technology that's out there. We are an engineering company based in New Zealand. We're part of the New Zealand geothermal community, and I just want to talk you through a few of our is that working on slide 2?
Fine, Chris. Yeah.
Is that all working? Okay, cool. So we're a company that's about 25 years old. I'm the founder and the current managing director of the company. I'm a mechanical engineer. I've worked in the power industry for about 40 years, just under 40 years. Today I was going to talk through a few of our projects we've done. As was introduced at the beginning, Turkey is a strong participant in the world geothermal family, and you are very close to or the similar power generation to us. So if there's any geothermal people in the room, I'd hope you'd recognise some of the designs that we've got in here and recognise them with the projects you have in Turkey. There's been a bit of discussion about distance, with New Zealand being a long way from Turkey. I've been working in Kenya for the last 8 years, and before the pandemic, I regularly travelled to Kenya for project meetings and to help deliver the project. The photograph that's in the slide is a Ngātamariki power station, which is one of the power stations in the central North Island of New Zealand. It's a binary plant power station, and the pond is used to collect brine and condensate, which is re-injected back into the reservoir for environmental reasons. We're a renewable power project company. We're a design company. We do designs for projects for both hydro and geothermal. And after 25 years, we've developed a range of clients around the world. And similar to Greg's comments before about his world map, we also work around the world with projects in New Zealand, Australia, Indonesia, Philippines, and Kenya. I would hope that we can add Turkey to that list shortly. A bit of a timeline of where we've been to as a company in the last 25 years, with a range of geothermal projects, both station projects, designing geothermal power stations, power plants, as well as designing the steam fields that feed the power plants, and a range of projects from detail design, preliminary design, owner's engineer, and projects around the world. Our core industries are renewable, geothermal and hydro, and we work a lot in the hydro industry in New Zealand. New Zealand has a very strong and a very long history of developing hydro power stations and operating them reliably. And we're part of the crew that delivers design solutions to maintain them, and we've designed new hydropower stations through the Pacific and through New Zealand. Our geothermal steam field and power plant design team. We are consulting engineers, and we like to be called engineers. We don't really like the term consultants because we are engineers. We're a team of about 30, 25 professionals in our Auckland office, and we deliver a range of design skills for projects. We're predominantly mechanical and process engineers. We have civil structural engineers to support our team for the projects that we deliver. The photograph here is a liquid ring vacuum pump for a geothermal power plant in the Central North Island. It's a station that I designed many years ago. I was part of the design team of. So this is Poipi, which is quite near where Greg lives in Taupo in New Zealand, around the centre of the North Island. And it was in Mike's picture before of the Geothermal Resources of New Zealand. This was delivered about 25 years ago. It was my first geothermal project, my introduction to geothermal. Extraordinarily fast project, and with the benefit of hindsight, the machine that was purchased for the power plant was an extraordinarily good purchase. The Fuji turbine, the Fuji generator, the Fuji equipment is very high quality and has delivered a very long period of sustained reliability for the owner, Contact Energy, for this power plant. I've always enjoyed working on this machine, and it's been an impressive machine. There's one thing about steam turbines is that they do have a long life if they're looked after, if you look after the chemistry. The other interesting thing about geothermal steam, which is a renewable energy source, is that a lot of the equipment that we use is very old in technology. The steam turbines date back to the Victorian era. Most of the piping standards we use date back to the early 20th century. And yet the projects continue to deliver higher efficiencies and better outputs as we go along with the tweaking of the engineering. And I'll talk a little bit further on about how we've used technology to help us deliver projects, even though the basis of our technology, our energy transformation is quite old technology. Ngā Tamariki Power Station, Central North Island. We were part of the design team. We designed the steam field, 7.5 kilometres of cross-country piping. This project won an award for its owner, Mercury Energy. It's got 4 Ormat energy converters in the plant. And again, it's operating quite reliably. One of the key aspects of this plant is that environmentally it has to re-inject all the fluid that extracts from the ground. So all the steam and the brine has the heat removed, and then it's re-injected back in the water to sustain the reservoir and reduce or minimise the environmental effects on the surrounding area. And that link to the environment is very strong in New Zealand, as Mike talked about before. There's a strong requirement to maintain and look after the environment through our Resource Management Act and our iwi engagement. Just down the road from Ngā Tamariki and Poipi is the Timihi Power Station. This is part of the Wairiki field, the first field developed in New Zealand for power back in the 1950s. And our role as MTL was to provide the process design to tie in the steam field for this 162 megawatt 2-unit Toshiba powered power plant into an existing steam field that operated 3 other power stations and maintained the operation of those 3 other power stations while we constructed the steam field that fitted everything together. I mean, it was a really challenging role, but fascinating from an engineering point of view of how we managed to make that work, working with the client and with local contractors like Greg's team. This is a pump station, the re-injection pump station. And if you're interested in pumps, these are very large, over 2 megawatts electrical input into each pump. And together they re-inject about 3,000 tonnes an hour of fluid back into the reservoir. Very large numbers. One of our overseas projects, Waiwindu 2, which is in Indonesia. It's in Java. An interesting part of the countryside with multiple geothermal power plants in a relatively small area. Lovely people, really enjoy my trips to Indonesia, and I really enjoyed my trips to site. Our role was to do the design of this cross-country cross-country steam field to deliver steam to the power station. two power stations side by side. Again, Fuji machines, again, very reliable. Karaha Bodas, which is quite near Waiangwindu. Our role was a detailed design. These projects are interesting from a technical point of view, but they're also challenging. Mountainous terrain, wildlife reserves or forestry reserves around the routes for the power plant, for the pipeline, sorry. And about, in this case, 22 kilometres of pipeline to find a route through mountainous terrain from the steam well pads through to the power plant. Interesting project. This is a recent project we did with a company, Supreme Energy, in Sumatra in Indonesia. They've delivered and developed over many years a number of geothermal power projects, and they're a sort of a company that's demonstrated that it takes a long time to develop geothermal projects, but you get there in the end. It's taken them years to develop this, but they've got some pretty successful projects underway now and operating. This particular project involved running a pipeline through an existing power plant, in fact, in a power plant that was under construction. So for us, there's a lot more constraints with working with a brownfield, with working around the construction activities, and also the final design with what's there, plus a future stage too, and trying to find a pipe route that fitted through all this. And this is where our technology came in, with the high resolution drone surveys, where we send 2 of our guys to site. We get a drone to do a survey, very detailed survey. And the information we get at a drone surveys now, the technology, is transformed in the last 5 years. It really is very impressive to what we used to get. And of course, that information that goes into our designs allows our designs to be a lot more accurate with the terrain that we're going through. But also it allows us to provide recognizable features for the owner to see when they're looking at our design and reviewing our design. So when we talk about why we're making design decisions, we can tell them, let them recognize the different parts of the plant that we're going around. It's a very powerful tool when you're communicating with a client. And with a brownfield environment where you have an intelligent client who knows their site well and has these other constraints that you don't always understand, then it's a very powerful tool that we use. And for us, the presentation of these drawings that we produce and the the ability to communicate with a client. And again, they're remote. Many of the meetings we had with Supreme Energy and Rekiasa, who are the contractor, were done remotely over Teams. With the drawings, the 3D model that you can spin around and talk to, with drawings you can annotate to get across the constraints and the meanings and the solutions that our team can provide for the different options we have. It's a very powerful tool, and it really has changed quite dramatically the use of the software and the ability to present things in the last 5 years. This is the area that we've had the biggest change technologically wise. One of our other projects is in Kenya, which I've been working on since the mid-2010s, 2015, 2016, I started this project. It's into construction and commissioning has started in the last few weeks. I really enjoy my trips to Kenya. I've had a wonderful time over there, and I've got good friends that I've developed from the Kenyan people that I've worked with over the years. And talking to Mike, who spent quite a bit of time there earlier on, and my team that have been over there, it's a place that we all enjoy going to. And the development that Kenya have done, I mean, they're extraordinarily proud of their plants they've delivered, and they're extraordinarily proud of their ability to maintain the operation of the plants over many, many years and keep the steam field running. So we've particularly enjoyed this project from a Kenyan point of view, and they've got development plans we hope we'll be part of in the future. This project we're doing alongside our German colleagues, Fichtner. They're a German consulting engineer in Stuttgart who we've worked with right through this project from the beginning. They look after the power plant owner's engineer role, and we look after the steam field owner's engineer role. It's been a great relationship for us. The design review process has been an extensive process, been a long process. There have been challenges with the design build process here, but we've worked our way through them with the client, and we've got a solution that's working at the end. So just looking at what we do, we cover a range of design tasks through a project from the beginning right through. We do a lot of HAZOPs, a lot of design reviews, and interestingly, our design reviews, HAZOP, safety and design workshops we've done in more recent times we've done over Teams, which is a challenging environment to try and run those risk workshops, but actually they're quite fun when you get a group of people in a room and you're trying to challenge a design in a positive way to get a better outcome. It's been quite an interesting experience. And thanks for your time today. I look forward to working with some of you in the future, and please be in touch with me if you have any queries. Thank you for your time.
Thank you, Mr. Mann. We also have Mr. Şemus Altan of Zorlu Energy with us. Şemus Bey, the floor is yours.
Thank you, Emin Bey. Hello to all participants. First of all, I would like to thank you all for the organization of this webinar. My name is Şemus Altan. I am Business Development Manager of Zorlu Energy Company. Zorlu Energy is one of the biggest IPP company in Turkey. Currently, we have 991 megawatt installed capacity, including hydroelectric power plants, wind, solar, geothermal, and so on. 87% of our installed capacity consists of renewable energy in Turkey. We are the market leader for geothermal energy in Turkey. Almost 20% of Turkey's installed geothermal capacity belongs to my company, Zorlu Energy. Besides that, we are also the market leader of electrical vehicle charging station in Turkey, with more than 1,200 charging points. We are looking for renewable energy investment opportunity and also open to discuss cooperation with New Zealand companies. Thank you to all.
Thank you, Şemus Bey. Now I would like to use the remaining time for Q&A session. If you have any questions, please let me know. Any questions?
Maybe I could just ask a question about the market conditions in Turkey for future geothermal developments and what you see the potential is in terms of growth. I think you've been quite generous in saying that New Zealand's 4th in the world and Turkey's 5th. I think, in fact, it's the reverse. I think Turkey has actually got more geothermal in New Zealand in megawatts, but I'd be interested to understand the market and how you see any development going forward.
I think Şemus Bey can answer this question. Şemus Bey?
Yes, Emin Bey. Recently, new updates in Turkish energy market. Actually, the government just announced the new feed-in tariff mechanism, new prices in Turkey. Before that, the tariff was foreign currency, dollar currency, but now new feed-in tariff is Turkish lira. It will be quite difficult to investors to make new investment because of the prices almost 30% decreased from previous feed-in tariff. Yes, there is also escalation method with dollar currency and also with inflation rate. There is also escalation for the feed-in tariff. But as you know, after the pandemic, there is quite difficulties to find equipment or supply equipment like previous price. For example, same, we just received offer from equipment producers, manufacturers. Maybe after pandemic, their just price is 50 or 60% higher than previous time. That creates a problem for the, I think it's because of the supply chain, break of the supply chain. So this is also one of the difficulties for the investors. If you look at the potential of geothermal in Turkey, actually it's around 60,000 megawatt thermal capacity was announced from government side for the exploration. So our installed capacity is just 1,650 megawatt in Turkey, geothermal installed capacity. We believe that it can reach till 3,500 megawatt. So there is opportunity to make new geothermal power plants in Turkey. I don't know very well the potential of New Zealand's geothermal capacity on the other hand, but Turkey, there is a big opportunity to make new investment. But when you compare with other price mechanism, it can create a little bit difficulties. It's not like a previous feed-in tariff. But there is still an opportunity.
Thank you very much.
You're welcome.
Thank you, Şemus Bey. Any other questions? Okay, as we finished the Q&A session, I would like to thank our ambassadors and guests for today's webinar. In 2022, the Turkey-New Zealand Business Council, we will continue our webinars and interactive discussions. Thank you for joining us today. Have a great day.
Thank you very much.
Thank you.
Thank you.
Thank you very much.
Thanks.